Hi, thanks for joining me in your journey of chemistry. Determining the number of significant figures is a significant or continually annoying issue for some of my students, and it can be challenging. But I hope a little kind of a trick that will help you figure out. If you're looking at somebody's reported value, our issue becomes, how do we know if we're looking at a number that tells me the magnitude of the value versus the number that tells me what my actual reliable measurement is? Okay, and we want to be able to determine the difference between these. If a number is about measurement, we're talking about significant figures. Now, magnitude are typically powers of 10. And where we run into, kind of the challenge of determining the number of significant figures are with zeros. They're the problematic ones. Right, there's some guidelines here that you can use that some people like, and I'll run through those quickly before I show you more of that kind of the trick that I learned. If it is a non-zero value, it's always significant. Non-zero values are never about magnitude. All right, the number one, is not going to be about magnitude. And so if you have a number and any non-zero value, so 1, 4, 8, has 3 significant figures. Okay, now zeros between non-zero digits are significant. So if this had been 1048, this would have been certain, uncertain digit, 4 sig figs. So if it's a zero sandwiched between two non-zero values, then it's going to be considered a significant figure. Now, if you have leading zeros, so if I have 0.004018, these zeros in front are considered leading zeros. And they're not telling me about measurement, they're telling me about magnitude. So leading zeros are never significant. 1, 2, remember sandwich zeros are significant. 3, 4 significant figures. Okay, now let's take a look at trailing zeros. I wish that I could give you a firm rule, but it really depends. And it depends on whether a decimal point is present. So if I had 10400, so these last two are trailing zeros. And there is not a decimal point explicitly. Yes, there's an implied decimal point, but there's not an explicit decimal point there. So if there's not an explicit decimal point, trailing zeros are not significant. They're telling us magnitude. So this would have 3 significant figures. If I had 104800, and then I put a decimal point there, that's how scientists tell us that these are now part of measurement. So certain, uncertain last digit. 1, 2, 3, 4, 5, 6, 7. Unusual number, but still. 7 significant figures. So trailing zeros are dependent upon whether or not there's a decimal place. Now, one of the beauties of scientific notation is that the exponent tells us magnitude. So my magnitude is right here, which means that every number in front of the times sign is communicating information about measurement. So with scientific notation, you don't have to worry about sandwich zeros, leading zeros, or trailing zeros. If it's scientific notation, everything in front of the multiplication sign is significant. So that number would have 3 significant figures. Now, if those guidelines didn't help, then maybe this trick will help. But I warn you, you have to know where your oceans are to do this. So the Pacific Ocean stands for present decimal. So whenever you have a number that has a decimal point, you're going to start on the Pacific side. So if we look down here, all of these numbers have a decimal point explicitly in them. And so we're going to start on the Pacific side. And we're going to count left to right. So now, if there is not a decimal point present, so for this number and this number, we're going to do the Atlantic or absent decimal and start going right. We're going to count right to left. Here we're going to count left to right. Okay. Now these are significant. This isn't scientific notation. These are easy peasy, no trick. Everything in front of the times sign is significant. That has 2, that has 3. Okay. It's these others that are tricky. So if we have 100, the rule is the same. It's only the direction you're counting. We always counted our first non-zero. So I'm going to start right and move left, and I'm not going to count till my first non-zero, which is right there. So that has 1 significant figure. Now, if I put a decimal point after that, now I have a present decimal. I'm going to start at the left, go to the right. You always start at your first non-zero. The rule's the same for both directions. 1, 2, 3. Once you start counting, you don't stop until you're at the end of the number. So this has 3. Okay. If I had 100.0 decimal present, so present decimal, start from the Pacific side, start at your first non-zero, 1, 2, 3, 4. So this has 4. Okay. Let's look at this number, present decimal. So you start from the Pacific side. Don't start counting till your first non-zero, which is right there at the 4. Once you start, everything counts. 1, 2, 3, 4. So this has 4 significant figures. Present decimal, start at the Pacific side. 1, 2, 3, 4, 5. Once you start counting, everything is included. Absent decimal, start from the Atlantic side. You don't start counting till your first non-zero, which is the 5. And then we count the 4 as well, so that has 2. Present decimal, start at the 9, everything counts. We have 4. Present decimal, don't start till your first non-zero, okay? And then don't stop until every digit, including zeros, is over. So this has 2 significant figures. This is a pretty, shall we say, significant concept in chemistry. So make sure you pay close attention and get lots of practice. Because if you're in my class, you're going to be dinged a few points for not recording things, especially in the lab, for not recording things to the correct number of significant figures, and including, you got it, units. All right, thanks so much for joining me. I appreciate your time.